Hi, I'm Brandon Graysley. I'm a high school math teacher. I'm going to explain how exponent laws work. This is what happens when we multiply or divide powers, and there's a rule there are a few rules actually when we have bases that are the same. So let me first of all explain what a power is. A power is any number or expression, a base, raised to some exponent. So here the base is 5. The exponent is 3. And the whole thing is called a power. Now sometimes we say 5 to the power 3 or 5 to the exponent 3, and that means the same thing. In both cases what it really means is we take the number 5, the base, and we multiply it by itself 3 times. And so anytime you have a positive exponent like this, and for now that's all we're going to do, this is what it means. Repeated multiplication is what an exponent gives us. So let's see what happens when we try to multiply together two powers that have the same base. So for example, let's take that 5 to the third and we multiply it by 5 to the fourth. And so I'm saying third because that's the third power, 5 to the fourth power, or the other way to say that is 5 to the exponent 3 times 5 to the exponent 4. Well, 5 to the exponent 3, that is 5 times 5 times 5. Maybe I'll put that in brackets just to show you the separation. It's not necessary. And then 5 to the exponent 4 is 5 times 5 times 5 times 5. So there are 3 of these here, and there are 4 of these here. That's what those exponents are telling us. Well, what we have really all together now is 1, 2, 3, 4, 5, 6, 7 of these. This is 5 to the exponent 7. And where that is coming from, or the other way to think about that, is this is the two exponents from before added together to give us 7. And in general, that's what that is our rule. That's called the multiplication law, is that when you multiply two powers that have the same base, you can instead add their exponents and use the same base, repeatedly use the same base. Okay, so let's do a couple more examples. Let's say I've got 7 squared times 7 cubed times 7 to the exponent 5. That would be the same as 7 to the exponent. I'm going to add all of these together. 2 plus 3 plus 5. And it's fine to write things in an exponent like that as an expression. And adding those all up, 2 plus 3 plus 5 is 10. So this expression is equal to 7 to the exponent 10. Okay, let's do another one here. How about 6 squared times 6 to the exponent 8. This one is 6 to the exponent. Let's add up the exponents for each of these different powers. The first one is a 2. The second one is tricky. It's actually a 1. That's our understood one. We don't typically write it there, but there is one. There is this power is 6 to the exponent 1, and this last one is 8. And so in the end we get 2 plus 1 plus 8 is 11. It's very tempting to not write anything here, to just have 2 and 8 is 10. But that multiplying by 6 gives us another copy of 6 that's multiplied together, and so our exponent is increased by 1. And so I've written it in there in red, and you can do that too. That's fine as a reminder for yourself. Now this doesn't just work with numbers, it works for any kind of base. So for example, if I have something like x to the exponent 3 times x to the exponent 5, notice I've used a dot there for multiplication. You can either smush these right next to each other, x to the 3, x to the 5, or you can put a dot, but it's not a good idea to use the little times x multiplication symbol because it looks too much like the variable. Anyway, these have the same base, and so I can add their exponents. This will be the same as x to the 3 plus 5, which is x to the exponent 8. Okay, now this is only true when the bases are the same though. So for example, if I took something like 2 to the exponent 5 times 3 to the exponent 7, there's nothing you can do there. You can't combine these other than to evaluate them, but you can't combine and rewrite them as a single power. That's not going to work. And that's also true with something like this. I have x squared y to the 5th. You're done. There's nothing else to do there. And you know what, maybe that's a smiley face. You're finished. So this is anytime you have two or more powers with the same base that are being multiplied together. We have something similar for when we are dividing powers. So if you have a power and you're dividing by another power with the same base, let's see what we have. It's called the quotient law. And in this case, let's start with 5 to the exponent 7 divided by 5 to the exponent 3. Well, let's rewrite this again. 5 to the exponent 7. Boy, I should have picked a smaller number. That's 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5. 6, 7 of those. And I'm going to divide by 3 5s multiplied together. Well, I'm going to write this as in the sort of fraction style with the division bar. Okay, the top here is 5 to the 7. The bottom is 5 cubed. Now, because these are inverse operations, multiplying and dividing, what I'm really doing is dividing by 5 3 times over. And that's going to, what we often say is it will cancel things here. This multiplied by 5 will be canceled out or undone by one of these 5s on the bottom that I'm dividing by. So we'll typically do something like this. We'll cross out one on the top and the bottom in pairs. Notice I'm replacing it with a 1 because what we're really doing is dividing it out. We have a times 5 divided by 5. That leaves a 1. Whew, okay, and so this is the portion that we are left with. Let's see what that is. There are 4 of those, so that's 5 to the exponent 4. But as you can see, what that really is, or where their shorthand for that, our rule, is going to be that we can take the we can subtract this exponent minus this exponent. 7 minus 3 is the new exponent that gives us 5 to the 4. And that's always going to be true whenever we take a quotient. Whenever we divide one power by another with the same base, we subtract their exponents to get the new simpler power. Okay, let's do a few examples. How about 6 to the exponent 7 divided by 6 squared? That's going to be 6 to the 7 minus 2 because it's division. That's a minus. 6 to the exponent 5. So how about this one here? 7 to the 12. We'll use division symbol again, divided by 7 to the 8th power. Let's see now. Oh, look, we have the understood 1 again. Let's write it in there. This is 7 to the 12 we're starting with. We're dividing by 7, so that's the exponent 1. We divide again, 7 to the 8, so we're subtracting 8. So those are the exponents, 12, 1, and 8. And because it's division, we are subtracting. If it was multiplication, we would be adding. 12 minus 1 minus 8 is going to be 3. So that's 7 cubed, or 7 to the exponent 3. Okay, so this one, we just got to watch that understood 1. We are dividing by 7. It has to have an effect, so we have to subtract it here in the exponent. And again, this works with variables, so maybe I have something like y to the 7 divided by y squared. I guess that's the same as the one we did up above here. 7 minus 2 is the exponent, which would be y to the 5th. Now we could also write this, for example, you might see this, y to the 7 divided by y squared. This is very common to see this, and you can just very quickly say, well, that's 7 minus 2, that's y to the 5. Okay, now, those two laws together will often happen in a single expression. For example, I might have something like 5 squared times 5 to the 8 divided by 5 cubed. Let's say I have that. So my exponents are 2, 8, and 3, but I've got a mixture of multiplication and division. I'm going to have, because they're all the same base, I'm going to end up with this base of 5. Let's start with 2. I'm multiplying by 5 to the 8, so I'm going to have to add that exponent. Then I'm dividing by 5 cubed, I have to subtract that exponent. Subtraction for the division, addition for the multiplication. So that will be 5 to the, let's see, that's 10 minus 3 is 7. This also happens with variables. Let's try this. X to the 6th, let's divide it by x. And hey, let's also multiply by x squared. I can just write it out there like that. When they're right next to each other like that, that's multiplication in between. So let me do this in two, well, here, we're going to end up with a base of x because all of these have the same base. X to the 6th divided by x, there's that understood 1 again. So I'm going to be subtracting 1, and then I'm going to be adding 2 to the exponent because I've multiplied by x squared. There are 2 copies of x here being multiplied. So 6 minus 1 is 5, plus 2 though gets us back out to x to the 7. Okay, so those are the two laws so far, and from that we get one more law, which is kind of neat, but is all it really is the multiplication law sort of repeated, and it's called the power law. And it's what happens when I take a power and I put an exponent on the whole thing, like this. Now what this means is 5 cubed times 5 cubed. Again, this is multiplication because I'm writing them right next to each other. I use brackets when I do that with numbers. So I've got 5 cubed times 5 cubed times 5 cubed times 5 cubed. Well, these all have the same base, and so I'm multiplying a bunch of stuff with the same base. I can just add the exponents together. That's 3 plus 3 plus 3 plus 3. Well, what's this? This looks like repeated addition to me, which I am familiar with as multiplication. This is 5 to the exponent 3 times 4. There are 4 of these, because there were 4 here, 4 here, 4 here, multiplying by 4. This is 5 to the exponent 12. This is how this always works. When you take a power of a power, you have the same base and you multiply the exponents together. And this is why, repeated addition of the exponent. And so we can use this a bunch of times. Let's try a few examples. 3 to the 5th power squared is 3 to the 5 times 2, which is 3 to the 10. How about this one? This is a big one. 7 to the exponent 3. We'll raise that to the exponent 9, and then we'll take that whole thing and square it, raise it to the 2nd power. That's going to be 7 to the 3 times 9 times 2. Multiplying that all together, 3 times 9 is 27. Doubling that, I get 7 to the 54. And also, oh, I'm sorry, I'm coming off the screen there. This also works fine with variables. If I have p squared and I take it to the exponent 4, that's the same as p to the 2 times 4, which is p to the 8. Okay, so those are the exponent laws, and you get to use that anytime the two bases are the same. And as I mentioned earlier on, if the bases are not the same, like this, there's nothing to do and you can't combine them. So you can only combine when you do have multiplied or divided or taken to a power with exactly the same base. Okay, I hope that helps, and if you need some more help, feel free to comment on the video, or hey, if you're in my class, you can always ask me. Thanks.